Morning, everybody. Today we're gonna continue chapter 1 and try to get through the equation part because this is the basis of all the rest of this course, understanding how to use the equations and finding points and graphing them. So when we do graphs, we can graph from equations. We can have something like 3x plus 2y equals 6, or we could have it in 2x minus 3, or it could be any type of equations. And we're going to talk about these a little bit later on. It could be something like that. The way if you're given equations, to graph equations, step 1. Determine the type of equation. And we're going to talk about that next class, which I give you all a worksheet in class where we'll fill it out. There are 12 different types of equations that we can deal with. Each one has their own basic shape. And then find some points. What kind of points? We're talking about the y-intercept. Basically, once you solve for y, so you get the equation y equals whatever. The y-intercept is the constant number, meaning it doesn't have a variable next to it. It's just whatever number is out there. All right, so then you can also find the x-intercept. It's where the graph crosses the x-axis, the horizontal axis. You do this by set y equal to 0 and solve for x. The x-intercept will always be in this form. It's going to be the equation. The y-intercept will always be in that form. So that's if they work. And the next step is once you find the points, point or points, follow the slope of that curve. All right. So that's pretty much, and then last step is connect the dots. That's the stuff we've been doing so far, graphing equations. Now, how do you find points? To find points of the graph or on the graph, choose any value for x plug it into the equation. So I had 3x, oh, that's not working. 3x plus 4y equals 12. First step, I pick any value for x. I'm saying that x equals, not x equals 1. Then I plug it in there. And then solve for y. So we get 3 plus 4y equals 12. Solve for y. Get rid of the 3 first. Twelve minus 3 is 9. And then divide both sides by 4. Y equals 9 over 4. 4 goes into 9 twice. That's 2, with 1 left over. If possible, plot that point. So our point is x was 1, and we have 9 over 4. And we can't plot that because we don't know what 9 over 4 is. So if not possible, choose another x value and repeat until you find some points. All right, so those are the outline of what we're going to be doing when we start graphing these things. And the other ones we'll be able to see what we need to graph those. In our graph, our first one we did, we had that point at 1, 1, 4, 5, 2, and we had another point at 5, 4. All right, we have those 2 points. Let me get a little ruler here. And we can connect the dots like that. There's our line. We've already figured out how to figure out the slope. The slope is m equals y2 minus y1, x2 minus x1. We got that. So here's our point 1. It's our first point, which is at 1, 1. This is our second point at 5, 4. We label the values. Because for the next equations we're going to need these anyway. So it's better to do it now. So x1 is the x value of the first point. x2 is the x value of the second point. y1 is the y value of the first point, and y2 is the y value of the second point. Plug those in there. y2 for y1 minus 1. x2 is 5 minus x1. So we get 3 over 4. That's our slope. Now, what does this mean? It has to mean something. It means slope. Slope we define as rise over run. But what does it mean with respect to our graph? This What this means is the relationship between any 2 points on the graph. The relationship between any 2 points on the graph. So if we see this, so we start at first point. We find a point, follow the slope. Remember, slope was rise if it's positive, down if it's negative, overrun. It's always positive. So from this one says it's positive, so we go up 3. 1, 2, 3. And this one's positive, so it goes to the right. 1, 2, 3, 4. So it's up 3 and over 4. That's what the slope means. So we can find the next point. Up 3, so it's going to be at y equals 8, and over 4. So add 4. So 8, 8. So up 3 over 4. Up 3 over 4. Now let's look at some other things we could find here. We could find how far it is from point 1 to point 2. How far is it from point 1 to point 2? Far, another name for that is distance. Right. And there's one formula we know for distance already. The Pythagorean theorem. A squared plus b squared equals c squared. The Pythagorean theorem works only with right triangles, which means you have to have a 90-degree angle in it. A represents one of the legs, the horizontal one. B represents the vertical leg, up and down. And C represents what's called the hypotenuse. The hypotenuse. And the hypotenuse is the distance from point A to point B. Basically, whenever you talk about the word distance, you're going to relate to this one. All right, so how does this relate to what we have here in our original equation? Do we have a right triangle? Well, yeah, as well. Let's look at this one. So we draw a horizontal line here through that point, and a vertical line here through that point, we have a right triangle. Or we could have done a vertical line here and a horizontal line through that dot, and we have another right triangle. So it doesn't matter how you do it, but you end up with right triangles, where A is the distance here, B is the distance there, and C is the distance between point 1 and point 2. So C squared equals A squared plus B squared. What we have to look at now is, well, how far is it from this point to that. So in other words, from 1 to 5, how far is it horizontally? What you always do is always take the second point and minus the first point. That's what we did on our formulas here. What this one says is, how far do we go up and down? We went up and down 4 minus 1, which is 3. How far do we run to the side? The distance here is 5 minus 1 is 4. So what that means, our A value is actually the distance between here, so between any two x's. So if this is our first x and this is our second x, then A is equal to x2 minus x1. That is our equation for the length of A. Same thing for B. Since we're going up and down, that's y1 and that's y2. So it's y2 minus y1. That's what B equals. So plug those back in here. So A, we know, was x2 minus x1 squared. B is the y values, y2 minus y1 squared. But remember, now we're talking about a distance, no longer a hypotenuse, we're talking about a distance. So we make this C becomes D. Now we have a saying, a definition to it. So that's your distance formula. To find the actual distance, to find D, square root both sides. So we have square root of D squared equals square root x2 minus x1 squared, y2 minus y1 squared. The square root and the square cancel, so the distance formula the actual distance is that. So there's your formula. Once you have 2 points, you have x1, y1, x2, y2. Remember, like I said earlier, once you define x1, x2, y1, y2, just matter of plug and play. So that finds the distance. So the distance in our 2 points, we know that x1 was 1. We know that x2 was 5. X1 is, or y1 is 1, y2 is 4. We're looking back at this graph here. So we're going to see what the distance is between these two. So 5 minus 1 squared, 4 minus 1 squared. 5 minus 1 is 4. 4 minus 1 is 3. 4 squared means 4 times 4, which is 16. 3 squared means 3 times 3, which is 9. 16 plus 9 is 25. Now, what times what, same number, equals 25? So the distance between our 2 points is 5 units away. So, okay, that's the distance formula between any 2 points. Let's look at an example. Because we have to have some negatives. Find M and D. So M is the slope. But first, before we do anything, we have to label our points. X1 is the X value of the first point. X2 is the X value of the second point. Y1 is the Y value of the first point. Y2 is the Y value of the second point. Get into the habit of writing down the equation whenever you're solving these problems. So now just look here. So y2 is -5 minus y1. Since it's negative, I put it in parentheses. Because this negative is from that equation. It has to stay there. X2 is 4. Minus X1 is -2. Okay, we can't have two negatives next to each other, or two signs next to each other, so a negative times negative is a positive. A negative and a negative is a positive. So our equation becomes -5 plus 3, 4 plus 2. Negative and a positive, they're different signs. 5's bigger, the answer is negative. 5 minus 3 is 2. 4 plus 2 is 6. So the answer is going to be negative. 2 goes into 2 once. 2 goes into 6 3 times. So there's our slope. Okay, now the distance formula. So we have x2 minus x1 squared, y2 minus y1 squared. X2 is 4 minus x1 is -2 squared. Y2 is -5 minus y1 is -3. Two negatives, so it becomes a positive. Two negatives, so it becomes a positive. Four plus 2 is 6. -5 plus 3. Again, it's negative because 5 is bigger. 5 minus 3 is 2. Six squared. 6 times 6 is 36. -2 times -2. This is what that means. Negative times negative is a positive. 2 times 2 is 4, so it's +4. 36 plus 4 is 40. For right now, I'll take this as an answer. And we're going to learn later on that we could simplify that even further. So that's the distance formula and the slope. Put my answers up here. Get -1/3 square root of 40. Those are my answers. Another thing we could find. Go back to our picture. We have a dot at 1, 1. And we have another dot at 5, 4. So far, we know the slope of this line is 3/4. Now we got to find the distance between the 2 points. So our points are 1, 1, 5, 4. Actually, didn't I do this already? Yeah, so distance is 5. Actually, I was going to show you also. Notice this value and that value. This equation and this equation is exactly the same as what's in the slope. y2 minus y1, y2 minus y1, x2 minus x1, x2 minus x1. So once you find the slope, what you could just do, you can skip all this stuff and just square the bottom number, square the top number, add them together, and square root them. That's a shortcut. So you could, that's a fast way of finding the distance. So we found the distance between these two is 5 units. The slope is 3/4. Another one we could find. It's called the midpoint. It's the location of the point halfway between point 1 and point 2. Halfway. That's the hint. How do we find halfway? So halfway between 10 and 20. We know it's 15. Halfway between 0 and 100. We know it's 50. So halfway simply means the average. The average is add the two numbers and divide by how many you have. 10, the beginning number and the last number, 10 plus 20 is 30, divided by 2 is 15. Zero plus 100 divided by 2 is 50. So that's what halfway means. So it's halfway between 1 and 5. So we found that by adding the two numbers and divide by 2. So it's going to be on that x value. Same thing here. So 1 plus 4, 2.5, or 2.5. It's going to be here. So there's the point, the midpoint. So what's the formula? Because it is a point, it's a midpoint. All points have to have an x and a y component. X and a y component. So the x component is horizontally. This is x1 and this is x2. So we add our endpoints, x1 plus x2 divided by 2. Same thing with the vertical ones. We take the first point, beginning the lowest and the highest, and divide by 2. And there's your midpoint formula. So in our example, x1 is 1, x2 is 5, y1 is 1, y2 is 4. Because we're using our 2 points, 1, 1, 5, 4. The midpoint. So write down the formula. So we have x1 plus x2 over 2. y1 plus y2 over 2. 1 plus 5 is 6, divided by 2. 1 plus 4 is 5. 6 divided by 2 is 3. 2 goes into 5 twice, and you get 1/2 at the end. 2.5 or 2.5, or anyhow you want to. That's the midpoint. An example of what you would use that for is, you see this a lot of times with ambulances, is if you're at home and somebody's really sick and here's a hospital, so they send an ambulance out. Instead of the ambulance going all this way and all this way back, you can say, listen, let's meet halfway. I'll drive the patient here, you drive this way, so you just have to go like that. So you actually cut the time down in half. All right, so those are your point, midpoint, your distance, and your slope. Now, if I ask you, what is the opposite of a line? A line is a straight graph. The opposite of it would be a circle. Let's talk about circles. What defines a circle? You have to have a circle is an infinite number of points. These are all points on the circle. There's an infinite number of them. That are all equidistant from a center point. Equidistance means they're all the same distance. They're all the same distance from a center point. Here's your center point. So all these points on our graph are all the same distance away from that center point. So that's So the equidistance, this equidistant is called the radius. It's like a spoke of a wheel. All right, so if you think about it, now we're dealing with distances, because that's the radius. If you think about it, when we talked about distances last, we talked about the Pythagorean theorem. That's what we use to find the distance between 2 points of a line in a triangle. We do the same thing to define the equation of a circle. All right, so let's look at this. If I have a point, remember this only works with triangles. Here's a center, there's that. So we have 2 points. We have the radius. Well, if we draw a line straight down, we have our 90-degree angle. So we have A and B, but the radius is always the same. The C value is always the same. Same thing if I put a point there. That radius has to be the same, and it causes a right triangle. Here's A, here's B. B is down there. There's my radius. Draw a line straight down to the x-axis, and there's my, this is A, this is B. So it doesn't matter where you are. You have A, and then you have B, and there's your radius. So we're going to use this equation, but instead of C for the hypotenuse, it's now the radius of the circle. So we have R. And remember, since these are distances, A is the horizontal, so it's x2 minus x1 squared, y2 minus y1 squared. Remember, it's a distance. But there's a big difference here. Yes, it's an infinite number, but this point here, the center never moves or changes. Because in the Pythagorean theorem, it's wherever point A and point B are. Once you have the center, it stays the same, so we can have the same radius on the other questions. So what we call that location we call it HK. The center is called HK. It never moves. So that takes place of our first point, x1, y1. So r squared equals x, because it could be any x, minus h squared plus y minus k, because that's the y value. And that is the formula for a circle. It's the equation of a circle with radius r and center hk. Example. Find the equation of the circle, which I'm going to call from now EOC, with center at 3, 4, and radius 2. Okay, remember, mathematics is a language. Once you know the words you're looking for here, you can define what equations you have to use. So what does this tell us? What formula? It says find the equation of a circle. Well, the only thing we know here, this is the equation of a circle here. So we have to use this formula. The center, remember that's HK. H is positive 3, and K is positive 4. And the radius is 2. So the only thing we can do is 2 squared is 4. And the rest, just leave it alone. And there's your formula. That's your EOC at center 3, 4, and radius 2. Now, let's take another example. Find the EOC with center at -5, 3, and radius 4. You're asked to find the equation of the circle. So that formula, x minus h squared, y minus k squared. Since this is the center, that's h and that's k. The radius equals 4. So r is 4, x minus -5 squared, y minus 3 squared. We have two negatives next to each other. Can't have that, so negative times negative is a positive. 4 squared is 16. And this is our equation. That's our answer. Now I want to point out something very interesting and important. It'll help us when we do some of these questions also. Actually, it'll help us from here on out in the course pretty much. Whenever you're solving for things and something's inside the parenthesis, we know that the numbers inside there, that's our center. You notice this one says -3 and this one says -4 inside the equation. The answer is always the opposite. If it's inside a parenthesis, the answer is always the opposite. So since this is -3, the answer I'm looking for the center is +3, and the y value is +4. So this is +5. The opposite is -5. That's the center. -3, so it's +3. So you can go both directions here. Let's do an example of that. Okay, an example. Find C and R of the following. Now remember, you always have, it's all based down to formulas. We're looking for a center. So we know the formula for a center is what? For a circle is r squared equals x minus h squared plus y minus k squared. So we have this, our center. So that's positive 2. So the center is at negative 2. That's negative 5. So the center is at positive 5. Why is that? Because what's happening here is, remember our original equation, if we drew a circle and our center's at 0, 0, and we had radius of 3. So we have the radius, x minus h squared, y minus k squared. So the radius is 3. The center is at 0, 0. So x minus 0 squared, y minus 0 squared. So we have 9 equals x squared plus y squared. Plus x minus 0 is x, y minus 0 is y. That is the standard one. That's from the center. If you move it, this one, I move it 2 to the left and 5 up. And the radius is up there. That's the center. What I want to see is what do I have to do to get it back to the origin? So if I took x plus 2 and put it equal to 0, x equals negative 2. So you have to subtract 2. That's what we got there. Likewise, same thing here. Y minus 5 said it equals 0. Add 5 to both sides. Y equals 5. There you have it. So that's the reason it's always opposites. Now the radius. The radius is not 9 because r squared is equal to 9. To get rid of the square, we have to square root both sides. Those cancel. Square root of 9. What times what equals 9? 3. So the radius is 3. Let's try another one. Find C and R of this one. Remember, this is an equation of a circle. The center, since this one has nothing around it, it's 0 because there's no plus or minus next to it. And it's opposite, so it's negative 3. So there's a center. And that, remember, this equals r squared. So square root both sides equals the square root of 5. Now, is it always that? No. I'll give you the same numbers, but I'm going to change one thing. Because this one equals square root of the equation, that means I know this is no longer r squared, because it's either going to be r squared equals x minus h squared y minus k squared, or if I square root both sides, so if the equation part here has a square root over it, that means this is already gone. Their square is already gone. So the center is at x is 0, y is -3, and the radius is 5, because we got rid of that square. So you have to be very careful when you do that. Oh, from here, to graph an equation of a circle, step 1, plot the center point. Step 2, from the center point, go r units, the radius, left, right, up, and down. And step 3, connect the dots. So let's look at this one. If I was going to draw that one, I would first plot the center, which is at 0, 3. There's a -3, I mean. So that's -3, that's the center. Now, the radius is 5, so I go up 5 from here. 1, 2, 3, 4, 5. Put it out there. Go to the right 5 spaces. 1, 2, 3, 4, 5. Put a dot there. And left. 1, 2, 3, 4, 5. And down. 1, 2, 3, 4, 5. And connect the dots. And there's your circle. That's all there is to it. Okay, so far we've also determined the slope. I gave you 2 points. You can find the slope. That's pretty quick and easy. If I give you a graph, I give you a graph. You can tell me the slope. You can tell me the distance between them. You can tell me the midpoint. You could tell me the y-intercept. The x-intercept, even though it looks like it's going through there, it's not for sure. We can't do that with just yet with a picture. And we could find, actually, we'll find the equation of line in a second. a line in slope-intercept form. The slope-intercept form is one we always think about. It's y equals mx plus b. A lot of people, when they think of slope, it's an equation of line, y equals mx plus b. Why is this? Because m is the slope and b is the y-intercept. Remember, how do you find the y-intercept? Set x equals 0. In other words, remove the x, and what you're left with is just y. All right, so that's the equation we'll be using. So what's our slope? Yes. You could figure out the points, 2, 3, 4, 5, and then plug it in the equation. Or since it's a graph, we have 2 points. Let's see how it works. So it's going up and down from here to here. How far is it up? 1, 2, 3, 4, 5. And then from here to here, how far is it running? 1, 2, 3, 4, 5. So the slope is 1. And the distance formula, we can figure that out. The midpoint, same way. So I'm not going to worry about that because it's time consuming right now. The y-intercept. The y-intercept is this one. We know it's the y-intercept because x is 0. So the y-intercept is at 0, -3. So our b value is -3. Remember, our m is 1, our b equals -3. So our equation m is 1 and b is -3. So 1 times x is x, positive times negative is negative, and there's your equation. All right, so what if I gave you this equation? Find m and b, or the slope and y-intercept. The slope is always whatever is in front of x. So the slope is -2/3. The b value, remember the equation is y equals mx plus b, so this is b. If it was a minus, then it would be a -5, a -5. But the y-intercept is a location, it's a point. It's at 0, 5. All right, so once you have the equation in that form, then just find whatever's in front of the x, whatever constant is. There's another example. Find m and b of this equation. Sorry. So to find m and b, first thing you have to do is solve for y. You want to put the equation in this form. Then locate m and b. So we have 3x plus 2y equals 6. We're solving for y. So we have to get rid of this. How do we get rid of positive 3x? Subtract it from both sides. These cancel. So 2y equals negative 3x positive 6. We'll get y by itself, so we get rid of the 2. Since it's multiplied, we have to divide each term by 2. Negative 3 over 2x. 6 divided by 2 is 3. So your slope, remember, always leave the slope as fraction. Your slope is negative 3 over 2. The y-intercept, since this is, remember, it's supposed to be y equals mx plus b. Since there's a plus, that means the b is 3. That means the y-intercept is 0, 3. The location of that intercept is at 0, 3. Yeah. Now, once we have m and b from linear equation, we can graph it that way. Graphing linear equations in y equals mx plus b form. Here are the steps. You can make sure get y equals mx plus b. Has to be in that form. Plot the b value on the y-axis. So here, what we could say here is find m and b. So m equals negative 3 over 2, b equals 3, or 0, 3. So we plot our b first. This is the y-axis. This is the x-axis. So we go, it's positive, so we go up 1, 2, 3. From that point, the b point, follow the slope. So the slope says negative 3. So we go down 3 from this point. 1, 2, 3, and over 2. And connect the dots. Let's try another one. Graph this equation. So remember our steps. The first step, you have to get it into this form. So here's the y. We have to get rid of x. It's a positive 5x. So we subtract 5x from both sides. Negative 5x, 10 is positive. Now, it's a negative 3 times y, so we have to get rid of the negative 3. Okay, now again, I'm trying to tell y'all, you can do what you want, but I guarantee you the negative signs will eventually come back and bite you. So do it in 2 different steps. First thing you have to do is get rid of the negative. How? Change all signs. So change that sign, change that sign, change that sign. Change all signs of each term. So it becomes a positive 3y, a positive 5x minus 10. Oop. Yeah, okay. And then we have to get rid of the 3. So the m, our slope is 5 over 3. It's positive. It goes up 5 over 3. And our y-intercept is at negative 10 over 3. Okay, notice that we can't really graph that one because it's going to be hard. So let's go back to the original equation. We know the slope is good. The slope is always going to be good, so we'll use that one. Go back to our original equation. Now, what can we do? We have to find one point. Since the y-intercept doesn't work, it's a weird intercept. So what if we put y is equal to 0? What if we find the x-intercept? If set y equal to 0, so we get 5x minus 3 times 0 equals 10. That becomes 0. So we have 5x equals 10. This is the x-intercept. Divide by 5. So x is equal to 2. Location is 2, 0. Remember, all you have to do is find a point. If the y-intercept doesn't work, hopefully it does. If it doesn't, then we find another point somehow. So we have it 2.2, 0, and the slope is 5, 3. So the slope is 5 over 3, and the x-intercept is 2, 0. So I know it's going to be 2, 0. Now from that point, we follow the slope. go up 5. 1, 2, 3, 4, 5, and over 3. 1, 2, 3. It's some weird number. So yeah, so there's our graph. We found a point, and from that point we went up 5, over 3. That's our slope. All right, that about does it for this class. The next class we're going to talk about is I'm going to give you a sheet. We'll do this in class. I'm going to give you a sheet. We're talking about functions. As I said, right now we're only looking at linear equations. I'm going to introduce you to what's called the library of functions. In high school, they call it the parent functions, but it's actually a library of functions because you have more than two parents. So that's why I don't like the term parent functions. All right, so this is it for today. We'll continue this. Actually, we should be able to finish up next class period, or actually, we'll definitely finish chapter 1 next week, and then you can take your first test, and then chapter 2 should be pretty straightforward. So we're on good pace. Don't worry about it. All right, everybody, have a great weekend and have good luck.